All right, so get this. You sent us a research paper, and it's about using AI to analyze these geological formations.
Really interesting stuff.
Yeah, it is. Specifically, it uses something called formation microresistivity imaging logs, or they call them FMI logs for short.
FMI logs.
FMI logs, yeah.
Okay.
It sounds pretty intense, right?
It is intense. These FMI logs are like super detailed X-rays of the walls of boreholes.
So we're talking about like oil wells and stuff like that.
Exactly. And they reveal all sorts of geological secrets. They're really important.
So they help you like see what's down there?
Yeah, you can see the different layers of rock and the structures within them. It's really amazing.
That makes sense, but where does the AI come in? How do they use AI to look at an X-ray of a borehole?
Well, researchers have figured out how to use a type of AI called a convolutional neural network,
Okay.
or CNN for short, to analyze these FMI images automatically.
So like the computer's looking at the image?
Yeah, it's like having an AI geologist who can scan through these logs and identify all sorts of geological features.
Hold on, an AI geologist. So they just feed a bunch of rocks to a computer and tell it to go find the oil.
Not quite. It's not that simple.
Okay.
It's all about pattern recognition. They trained this CNN on thousands of images of various geological features,
Okay.
different types of rock formations, fractures, faults, you name it.
And then it learns.
By analyzing these images, the AI learns to identify these features on its own.
So it's like teaching the AI to see the same patterns that a human geologist would see.
Precisely. And the researchers fine-tuned the AI's learning process until it could identify over 50 different geological features with an incredible 92% accuracy.
92%, that's really high.
It is very impressive.
But how do we know it's actually understanding geology and not just memorizing the images it was shown?
That's a great question, and that's where it gets really interesting. They tested the AI on a set of 100 brand new images it had never seen before.
Oh, wow. Okay.
And guess what? It still achieved over 86% accuracy.
Wow. Okay, this AI is the real deal.
It's definitely a powerful tool.
Yeah, but I'm still trying to wrap my head around why this is such a big deal. What are the implications of having an AI that can analyze geological data like this? Why should we care?
Well, think about it. This could completely change how we explore for oil and gas.
Okay.
Instead of relying on manual interpretation of these complex FMI logs, we could have AI doing it much faster and more accurately.
So potentially faster discovery of new oil and gas reserves.
Exactly. And that's huge, especially with the world's energy demands constantly increasing.
Yeah, for sure.
And it's not just about finding oil and gas.
Yeah.
This technology could also revolutionize how we understand things like earthquake, risks, geothermal energy potential, and even the stability of underground structures.
Okay, I'm starting to see the bigger picture here, but before we get too carried away with all the amazing possibilities, let's zoom in on the research itself. You mentioned they use a confusion matrix to analyze the AI's performance. What exactly is that?
A confusion matrix, it's basically a visual representation of how well the AI is doing at identifying different features.
Mm.
It shows us not just overall accuracy, but also what types of features it's good at identifying and where it might be struggling.
So it's like a report card for the AI geologist,
Yeah, you could say that.
highlighting its strengths and weaknesses.
Exactly. And one thing that stood out in the confusion matrix was how well the AI performed at identifying imbrication, which is this specific overlapping arrangement of rocks.
Imbrication, huh? Sounds complicated.
It can be even for trained geologists,
Yeah.
but the AI nailed it, achieving a perfect score in that category.
Okay, so the AI aced that part of the test. What about the areas where it struggled?
Well, it had a slightly lower accuracy when it came to identifying features like dewatering fabrics or rill marks.
Hmm.
These features are a bit more subtle and less common in FMI logs, so the AI might not have had enough examples to learn from.
That makes sense. It's like trying to learn a new language, but only being exposed to a limited vocabulary. You're going to struggle with the more nuanced expressions.
That's a great analogy, and it highlights the importance of having a diverse and robust data set for training these AI models. The more examples they see, the better they become at generalizing and making accurate predictions.
Okay, so we've got this AI geologist that's pretty darn good at identifying geological features, but it still has some room for improvement. I'm curious, though, how do they actually measure its performance beyond just overall accuracy?
That's where things like precision recall and F1 score come in.
Okay.
These metrics give us a more detailed understanding of how well the AI is doing for each individual feature.
All right, break those down for me. What exactly do those metrics tell us?
Well, let's start with precision.
Okay.
Precision tells us how often the AI is right when it says, this is a fault, or that's a fracture.
Okay.
So a high precision score means it's making really reliable calls.
So it's not just taking like wild guesses.
No, not at all.
It's actually making informed decisions
Right.
based on what it's learned. That's really cool.
It is, and remember that imbrication feature where the AI got a perfect score?
Yeah.
Well, it also had perfect precision for that,
Oh, wow.
meaning it never misidentified that feature.
So it's like the AI has a special talent for imbrication.
You could say that?
For spotting those overlapping rock formations, were there any areas where the precision wasn't as high?
Yeah, there were a few. For example, it had a slightly lower precision score for something called herringbone cross stratification,
Okay.
which is another type of sedimentary structure.
Another complicated one.
Yeah, this one's a bit tricky.
Okay.
And the lower score suggests the AI might occasionally misclassify that feature.
That makes sense. Even a super smart AI is going to have its strengths and weaknesses.
Yeah.
What about recall? How does that fit in?
Recall is all about making sure the AI isn't missing anything important.
Okay.
It measures how well the AI is able to catch all the relevant features that are actually present in the FMI logs.
So it's not just about being right when it makes a prediction.
Right.
It's also about not overlooking anything crucial.
Exactly. You don't want it to miss anything important. And the AI did really well on recall for features like bounding surfaces, lamination, and oversteep bedding.
Wow, it remembered all those.
It did. It consistently identified those features when they were present.
That's reassuring. It sounds like this AI is doing a good job of not missing those key geological features. Were there any areas where the recall score wasn't as strong?
Yeah, there was one. The recall for dewatering fabrics was a bit lower,
Okay.
which again suggests the AI might occasionally miss these features in the logs.
Because they're subtle?
Exactly. They can be very subtle and hard to spot.
Okay, so we've got precision and recall. What about the F1 score? You mentioned that one earlier, too.
Well, the F1 score gives us a single score that balances both precision and recall.
Okay.
So it essentially tells us how well-rounded the AI is in terms of accurately identifying features. And not missing any important ones.
So a high F1 score means the AI is doing a good job overall.
Exactly. And many features like imbrication, color modeling, and adhesion ripples and warts all had very high F1 scores.
It's indicating that the AI is performing well across the board.
So it's like a good all-around student.
Yeah, that's a good way to think about it.
Okay, so all these metrics are pointing to the fact that this AI is pretty darn good at what it does. It's like having a superpowered assistant for geologists.
I'd say so.
But, even with all these impressive results, I'm curious about the real-world applications. How would this technology actually be used in the field?
Well, one of the most immediate applications is in oil and gas exploration.
Okay.
Imagine you're an exploration geologist tasked with finding new reserves.
Okay.
Traditionally, you'd spend countless hours poring over FMI logs, seismic data, and core samples, trying to piece together a puzzle of the subsurface.
Oh, wow. That sounds like a lot of work.
It is. It's a very time-consuming process.
Yeah.
And it's also prone to human error.
Right, because we get tired.
Exactly. But with AI, you can automate much of that analysis. The AI can sift through mountains of data much faster than a human, and it can pick up on subtle patterns that might be missed by the human eye. It's like having an extra set of superpowered eyes helping you find those hidden pockets of oil and gas.
That's a great way to put it.
And that could significantly speed up the exploration process, right?
Absolutely, and that's not all. The AI could also help identify the most promising drilling locations, reducing the risk of dry wells, and ultimately making the entire process more efficient and cost-effective.
This is starting to sound like a game changer for the energy industry.
It has the potential to be.
But you mentioned earlier that this technology has implications beyond just oil and gas. What other areas could it be applied to?
Oh, the possibilities are vast.
Okay.
Let's take geothermal energy, for example.
Okay.
It's a clean and sustainable source of energy. But finding the right spots to tap into geothermal resources can be a challenge.
It's like trying to find those hot springs hidden deep beneath the Earth's surface, right?
Exactly. You need a deep understanding of the subsurface geology, the location of hot rocks, and the pathways that allow water to circulate and bring that heat to the surface.
Right.
And that's where AI comes in.
Okay, so how does AI help us find those geothermal hotspots?
Well, by analyzing data from FMI logs, seismic surveys, and other sources, the AI can pinpoint areas with the right combination of geological features to support a viable geothermal system. It's like having an AI-powered geothermal scout guiding us to the most promising locations.
That's amazing. So we could potentially accelerate the development of geothermal energy and reduce our reliance on fossil fuels.
Precisely. And the benefits don't stop there. AI can also be used to monitor and manage existing geothermal plants, making sure they're operating efficiently and safely.
This is incredible. We've talked about oil and gas, geothermal energy. Are there any other fields where this technology could make a big impact?
Absolutely. Think about earthquake risk assessment.
Oh,
Earthquakes are incredibly complex, but AI can help us analyze massive amounts of data to identify patterns and precursors that might signal an impending quake.
so it's like the AI is looking for subtle clues that the Earth is giving us clues that might warn us of an earthquake before it happens.
You got it. AI can analyze data from seismic sensors, GPS stations, and even changes in groundwater levels to detect subtle shifts and stresses in the Earth's crust.
Wow, that sounds almost like science fiction.
It does, but it's becoming a reality.
But it could also save countless lives and reduce the devastating impacts of earthquakes.
Absolutely. It's about moving from a reactive approach to a proactive one, using AI to anticipate and prepare for earthquakes rather than just responding to them after they occur.
And it could help us design more earthquake-resistant structures and infrastructure, making our cities and communities safer.
Exactly. But the applications don't stop there. AI can also be used to predict and prevent landslides, identify potential sites for carbon capture and storage, manage groundwater resources, more effectively monitor the stability of mines and tunnels, and even explore for new mineral deposits.
Wow, the possibilities seem endless. It's like AI is unlocking a whole new level of understanding when it comes to the Earth and its resources.
I agree, and the research we've been discussing, this analysis of FMI logs, is just the tip of the iceberg. As AI technology continues to advance, we can expect even more groundbreaking discoveries and applications in the years to come.
It's truly an exciting time to be following these developments, but, as much as I love hearing about all the amazing things AI can do, I also think it's important to be mindful of the potential challenges.
I completely agree. While the potential of AI in geology is immense, it's crucial to address the limitations and ensure we're using this technology responsibly.
So, what are some of the key challenges that researchers and industry professionals are grappling with?
One of the biggest challenges is the issue of bias in AI algorithms.
Okay.
AI models are trained on data, and if that data is biased in any way, the AI's predictions will also be biased.
So, if the data used to train an AI is skewed towards certain types of geological formations or regions, it might not perform as well in other areas or with different geological features.
Exactly.
Yeah.
This is why it's so important to make sure that AI models are trained on diverse and representative data sets that capture the full range of geological conditions.
It's like teaching someone to cook, but only showing them recipes from one specific cuisine.
Right.
They're going to be lost if you ask them to make something completely different.
That's a perfect analogy. We need to train AI models to be geological chefs who can handle any type of geological data they're given.
Another challenge we touched on earlier is the black box problem. It's great that these AI algorithms are so powerful, but sometimes it's hard to understand how they arrive at their conclusions.
Right. It's like the AI is giving us these amazing insights, but we don't always know what logic or reasoning it's using.
Right, and that can make it hard to trust the AI completely. It's like getting advice from someone but not knowing where they're getting their information from.
I see your point, and that's why researchers are actively working on developing more transparent and interpretable AI models.
Hmm.
They want to be able to peek inside the AI's decision-making process and understand the factors driving its predictions.
So it's all about making the AI's reasoning more visible and understandable.
Exactly. That not only helps us build trust in the AI, but it also allows us to identify any potential errors or biases in its logic.
That makes a lot of sense. It sounds like the research community is really taking these challenges seriously and working to create AI systems that are both powerful and trustworthy.
They are. And as the field of AI in geology continues to mature, we can expect even more robust and reliable systems that can help us unlock the secrets of the Earth and address some of humanity's most pressing challenges.
This has been an incredible journey so far. We've gone from the nitty-gritty details of FMI log analysis to the broader implications of AI for the future of geology. But, there's one more aspect we need to explore, and that's the ethical considerations surrounding this technology.
That's a crucial point. As AI becomes more ingrained in our lives, and particularly in fields like geology where decisions can have significant consequences, we need to carefully consider the ethical implications.
Yeah. Okay, so let's dive into that in the final part of our deep dive. What are some of the ethical questions we need to be asking as we integrate AI more fully into the world of geology?
Okay, so we're back, and we've talked about AI analyzing these FMI logs, finding oil and geothermal hotspots, and even predicting earthquakes.
Some really incredible applications.
Yeah. It is, but now it's time to, like shift gears a little bit
Okay.
and address the elephant in the room.
The ethical consideration.
Yeah, the ethics of all this.
It's important.
It is any technology this powerful, requires careful consideration of its ethical implications.
Especially in a field like geology where the stakes are high.
Yeah, exactly.
Yeah.
So where do we even start? What are the biggest ethical questions we need to be asking as we, bring more AI into the world of geology?
Well, one of the first things that comes to mind is data privacy.
Okay.
Geological data can be incredibly sensitive.
In what way?
Well, it reveals information about land ownership, resource potential, and even potential environmental hazards. Oh, so that's private information that people don't necessarily want out there.
Exactly.
So if AI is analyzing all this data, how do we make sure people's privacy is protected?
That's a great question, and it's something that researchers are actively working on.
Okay.
We need to develop really strong data governance frameworks.
What does that look like?
Think clear guidelines about who can access what data, how it can be used, and what safeguards are in place to prevent misuse.
So it's like a set of rules for how to handle this data responsibly. It's
Exactly.
a tricky balance, right? Wanting to use this powerful technology, but also, respecting individual rights and protecting sensitive information.
It is, and it requires ongoing conversations and collaboration between researchers,
Hmm.
industry professionals, policymakers, and the public.
So it's not just a technological challenge.
No, it's a societal challenge.
It's about figuring out how to use this technology ethically.
Right. How to harness the power of AI without compromising privacy or security.
Another concern that comes to mind is the impact on jobs.
Oh, yeah, that's a big one.
If AI can automate tasks that geologists used to do, what happens to all those jobs? Are we going to have a bunch of geologists out of work?
It's a valid concern and something we need to be mindful of. But AI is unlikely to completely replace human geologists.
So it's not about AI taking over,
No.
but more about AI working alongside geologists.
Exactly. Think of it as AI augmenting human capabilities.
Okay.
AI can take care of those repetitive, data-heavy tasks, freeing up geologists to focus on things that require creativity, critical thinking, and complex decision-making.
The things that humans are good at.
Exactly. The things that AI isn't so good at.
So it's like giving geologists a powerful new tool in their toolbox,
Right.
not replacing the entire toolbox altogether.
That's a great analogy. And this shift could actually create new opportunities, leading to jobs in fields like AI development and data science within the geosciences.
So it's not just about job displacement. It's also about job evolution and the emergence of entirely new career paths.
Exactly. The key is to make sure that geologists are equipped with the skills and training they need to thrive in this new AI-powered landscape.
To adapt to this new way of working.
Right.
Okay. We've talked about privacy and jobs, but I keep thinking back to that black box problem we discussed earlier.
Yeah, the lack of transparency.
Yeah, how can we make sure that AI is being used responsibly in geology, especially if we don't always understand how it's arriving at its conclusions?
That's where transparency becomes crucial.
Okay.
We need AI systems that are accountable where we can understand how they work and why they're making certain recommendations.
So it's not enough to just get an answer from the AI.
Yeah.
We need to understand the logic behind that answer.
Exactly. And we need to make sure human experts are always involved in the decision-making process.
Right.
Using AI as a tool to guide their expertise, not blindly following its every suggestion.
So it's like having a co-pilot,
Right.
not an autopilot.
That's a great way to put it.
Yeah.
The human is still in control.
And this is why ongoing research into more transparent and interpretable AI models is so important.
It's essential.
The more we can understand how these AI systems work, the better we can ensure they're being used responsibly and ethically.
I completely agree.
This has been such an eye-opening conversation. We've gone from the depths of the earth to the heights of ethical considerations, all thanks to the incredible power of AI.
It's been a fascinating journey for sure, and I think it highlights the importance of having these conversations, of thinking critically about the technologies we're developing and the impact they'll have on our world.
I completely agree. This is just the beginning of the AI revolution in geology. There's so much potential, but we need to proceed thoughtfully and responsibly.
Well said. The future of geology, and frankly many other fields, is intertwined with the future of AI. It's up to us to shape that future in a way that benefits all of humanity.
And to our listeners, if you're eager to learn more, we highly recommend checking out the research paper we've been discussing.
Yes, definitely.
Real-time identification of geological factuals by integrating formation micro-resistivity imaging logs with computer vision.
A mouthful.
Yeah, by Amr Gharib and his colleagues.
It's a great paper.
It's a fascinating read that will give you an even deeper understanding of this groundbreaking field.
And until next time, keep those questions coming and never stop exploring the world with a curious mind.
That's a wrap for this episode of The Deep Dive. Thanks for joining us on this journey into the world of AI and geology.